let's talk about loops, specifically for loops and for each loops, because while they're very similar, there's minute differences between the two of them. So far in this project, if you haven't been keeping up, that doesn't matter. This can just be watched on its own. We've had this key that we can pick up, and I'll just show you, actually. We can go pick up this key, and it will destroy the key, and then it will enable our hasKey bool, which will then allow us to go through one of these doors, at least in theory. At the end of a previous tutorial, I changed up the code for the doors, so that doesn't work like that anymore. Doesn't matter, we're going to be changing it anyway right now. Because we're going to be changing it into a system where if we pick up the key, it will delete all of the doors that are linked to that specific key instead. So how do we do that? I've already made a key door opener script. It's a very descriptive name, I know. And if we open up this script, it's empty. And we can make a public game object array, and we'll call that doors. Now, in the Unity editor, we've got this array here, and we want to delete 3 different doors. So we can just go select this door over here, and we can drag in these 3 doors into these game object slots. Now that we have a reference to all these 3 doors, we can influence them. But how do we all influence them at once? That's where for loops come in. So let's make a quick function here called void delete doors. In this function, we're going to put a for loop. And in this function, we're going to make a for loop. So we write for and then 2 parentheses. Actually zoom in so that you can see a little bit better. And the first thing we do is we initialize a variable where we're going to be counting the amount of loops we use. So that will be an integer. Traditionally we call that integer I, but you can really call it whatever you want. And we'll set that equal to 0. Then we separate this with the next bit through using a semicolon, just like you do with the end of a line of code. The next part is going to be the condition. So as long as this condition is true, the loop will keep on going. Usually we compare the I variable that we just made to a different number. And in our case, that will be our doors.length. So however long the doors array is, that's how many times we're going to loop through whatever code we're going to create here. Then another semicolon. And then the last bit we need is the incrementer for every time we loop through. Usually this is just I++, meaning that I increments by 1. All of this, you can make any variable you want here. You can use any condition you want here, and you can use any amount of incrementation you want here. This is more or less 99% of the time what you're going to use though. Then we put on 2 brackets and we put in the code that needs to loop within those brackets. And for this, it's actually pretty easy, because what we're going to do is we're going to just say destroy, because we need to destroy one of the objects. And the predictive text here is entirely correct. We're going to destroy doors and index number I. Let's go over that real quick so that you really understand what we're doing here. We've gone over the destroy function before. We're going to destroy the game object of our variable doors, but since doors is an array, if you haven't seen my video on arrays and lists, go watch that one for a little bit more context. Because as we know, arrays have a number of indexes. So we need to specify which index, which object that's stored inside of that array is going to get destroyed. And that will be the index that's equal to our current I value. So our current loop through. Meaning that the first time we loop through this is going to destroy index 0 out of doors. Then it checks, okay, is I less than doors.length? Yeah, it still is, because doors.length is 3. So it will increment I and go through this again. And now it will destroy the doors I, in this case, is 1. So it will destroy index number 1 in our game object array. Then it will check again, is I less than doors.length? Well, doors.length hasn't changed, it's still 3. So it will increment again and go through until this isn't true anymore. So if we put a on trigger enter 2D here, and we just put in that delete doors function that we've just made, and I comment out some of the old code that we used before, we'll be able to see that if we run into this key now, all 3 doors instantly disappear. It doesn't delete the key though, because I just commented out that code. So you can just go back into your delete doors function, and under the for loop, then we can just destroy this game object. So as you can see, now it will destroy all 3 doors and itself. That's a for loop. Now we're going to delete that, and instead we're going to make a for each loop. A for each loop does the same thing, but it's specifically designed to work with arrays and lists. A normal for loop you can use for a variety of different situations, because you initialize your own variable and you set your own condition and you set your own incrementation. A for each loop simplifies it all for you as long as you're working with an array. So the way we use that is we say for each game object, and then we give that game object a name, let's say instance, and then we specify in which array. So for each game object in our doors array, we will do something, which in this case is just destroy that instance. And you'll be able to see that the functionality is exactly the same with a slightly different piece of code. In reality, it's not even that different, but you can see this looks a lot more straightforward and it takes up a lot less space. You have to do a lot less manual stuff. So for each loops, they're really, really nice to use. Still doesn't hurt understanding how to and when to use normal for loops as well. A downside to the for each loop though is, as you can see here, I'm trying to write to our instance variable, our game object here, and we're getting a error because of it. Property or index or game object transform cannot be assigned. It is read only. So you can't write to these variables. You can only read from them. And since you don't have a I variable that's incrementing through every single time that you can access, it's also a little bit more difficult for a for each loop to count at what point in the loop it is. If you want to make a loop that every 10th time, for instance, adds something to your score, it's much more straightforward to do that with a normal for loop. But if you just need to have a list or an array of objects destroyed or assigned to a certain place or whatever, that's where for each loops become very, very useful. It's simpler, it's much more straightforward, but it's also slightly less flexible. And a very big thank you to all of my Patreons. You can see them on screen right now. If you want to help out supporting the channel, there's a link down below in the description to the Patreon page.